Typically after a collision, in the past, the body had to be repaired, the frame had to be straightened, lights had to be reconnected, fairly cut and dry. Now when you start putting on sensors on the vehicle, cameras, radars, ultrasonic sensors, that kind of changes the picture because they get damaged or the sheet metal gets damaged, and then you straighten everything out. Well, now where are they pointing? Where's the radar pointing to her? Where's the camera looking at? So obviously the original equipment manufacturers, the OEMs, have position statements, and they say that if X happens to the car, then we must now follow this procedure to re-aim or recalibrate these sensors. There was a lot of pushback from the body shops because they were simply saying, well, we don't need to do any calibrations because there's no lights on the dash and there aren't any fault codes. Well, there won't be any lights and there won't be any fault codes, but it still could be out of calibration because it doesn't know what it's looking at. We have to put something in front of it. We have to measure out how far in front of the sensor to place a target. That distance has to be measured within 1 millimeter, and it has to be within 1 degree of center line. That's a known fixed object in a space. When it looks at that target, now the computer is counting on us, I say us technicians, to put that target in the right spot. So if this is the target and this is the sensor and the target's where it's supposed to be, when we shoot it, everything's fine. But what if I'm just 1 degree off? Well, the computer's counting on us to put that target in the right spot. It looks and says, okay, that must be where the target's supposed to be. Well, if I take that 1 degree now and I extrapolate that out 150 to 200 feet, now that 1 degree becomes several inches or several feet, and we may not even see the car in front of us, or we may delay when we do see the car, and now the safety systems are not going to work as designed. So what I call that is a false positive. There's even some people out there that put the target here, the car's here, and it fails the calibration, so then they move the target until it passes. Like, no, don't do that. The target has to be in the right spot. There's something else wrong. Maybe the bracket's bent. There are so many ways to produce false positives where it passes, but is it correct? The only way we know it's correct is if we set it up perfectly every time. And that's where the measurements are critical.